In this video we're going to look at compound angles. These are some of the formula that are in the logbooks. Okay, so here they are. All those. You don't need to know them off by heart, they're in the logbooks, but you need to know how to use them. This is not too hard, to be honest. So I'll just give you an example. So here we have a unit circle, and we have angle A, and that's kind of in the yellowy orange colour, and we have angle B then in the blue colour. And the angle then A minus B is this red bit here, okay? And I want to find out the sine of that angle. If we look over here, I want to find out the sine of A minus B. So how I do that is I take this formula here. Sine A minus B equals sine A cos B minus cos A sine B. Right. If we look over here, I'm just after saying that angle B is 30 degrees and angle A is 45. Okay, it doesn't look 45, but let's just say it is. Okay, and now I've just found the sine of 45, the sine of 30, the sine cos of 45, and the cos of 30 from my logbooks. And with that information, I'm going to find the sine of A minus B. So here we go. So the sine of A minus B is the sine of, I'm taking it from over here, is first of all sine A. So sine A is the sine of 45, which is 1 over root 2, multiplied by the cos of B. So the cos of B is the cos of 30, which is root 3 over 2, minus the cos of A, and that's the cos of 45, which is 1 over root 2, multiplied by the sine of B, and that's the sine of 30, which is half. And all I do then is I multiply these two together, I multiply these two together, I minus them from each other, and then that will give me the sine of A minus B, which will be the sine of this angle. Okay? Right, so we'll just do 3 examples to show these. So this is generally the type of questions you'll get. So it says prove sine A plus B over cos A multiplied by cos B equals tan A plus tan B. Right, the first thing we're going to do is go look at the left hand side, and we're just going to multiply it out. So sine A multiplied by sine B is sine A cos B plus cos A sine B. And I get that from my formula book, okay, which is the exact formula we used in this. So here it is. So that's that one there, so we're using that. Right. And that's all going to be over cos A cos B. And we want to show that that equals tan A plus tan B. Right, we know from the last video that the tan of theta equals the sine of theta over cos of theta. We know that from our logbooks too on page 13. So if I can get over here parts of it to look like sine A over sine A over cos A, well then I can say that that equals tan A. Okay, so that's my logic here. Right, so what I'm going to do is I'm going to take this sine A cos B and this cos A sine B as the numerator and the denominator, the cos A cos B, and I'm going to multiply top and bottom by cos B. and you're going to see why now in a second. So sine A over cos A, and then cos B over cos B. So I've multiplied it all. Okay, so I've multiplied this section by cos A, cos B. I'm going to do the same over here. So it's cos A sine B, and I'm going to divide that by cos A cos B again. Okay, so I'm going to basically every part of this fraction. I'm going to divide every part by cos A cos B. Likewise, on this denominator, we have cos A cos B on the bar or on the top, and I'm going to divide that by cos A cos B, and that will equal tan A plus tan B. I just have to prove it. Right. Well, if you look here, the whole reason I did this is because now I can cancel out this and this. I can cancel out this and this, and these all cancel to 1. So what I'm left with then is sine A cos A plus sine B cos B all over 1. Again, we have our tan A, tan B on the left hand side. If I can just bring it over here in the room, sine A cos A, based on this, I can say that's tan A, and I can say this bit here, sine B cos B, again based on this, is tan B, and that's still over 1. We have tan A plus tan B on this side, and tan A plus tan B over 1. Well, that does equal tan A plus tan B. So tan A plus tan B then equals tan A plus tan B. So I have proven it. Okay, so the next question says express sine 15. Okay, so this is question 1. Express sine 15 in surd form. If you look at your logbooks, right, they only express certain angles in surd form. Okay, so they'll express 30 degrees, 45 degrees, 60 degrees, 90 degrees in surd form. They won't express 15 degrees in surd form. However, we can use a clever trick here. So we can say, well, sine 15 degrees is the same as sine 60 degrees, which we do know is in surd form in the logbooks, minus 45 degrees, which again is in surd form in the logbooks. Okay, and that is basically sine A minus B. And looking back here, sine A minus B is sine A cos B minus cos A sine B. Right, so here we go then. We have our sine of 60 degrees minus 45 degrees is the same as, we look over here, sine of 60 multiplied by the cos of 45 minus the cos of 60 multiplied by the sine of 45. Now I'm going to change all this into surd form first. So we have sine of 60 degrees, sine of 45 degrees, cos of 60 degrees, 45 degrees. And we can get these from our logbooks. Okay, so there they are. So the sine of 60 minus the sine of 45 is the same as the sine of 60 degrees multiplied by the cos of 45 degrees minus the cos of 60 degrees multiplied by the sine of 45 degrees. So concentrating on this bit here, remember we want to write it in surd form, so the sine of 60 is root 3 over 2 multiplied by the cos of 45, which is 1 over root 2, minus the cos of 60, which is a half, multiplied by the sine of 45, which is 1 over root 2. And that then will give us, if we multiply this bit together, we will get root 3 over 2 root 2 minus 1 over 2 root 2, and leaving it in surd form we have root 3 minus 1 over 2 root 2. So there it is in surd form. So now we're going to get the tan of 105 in surd form. Again, we don't have in our logbooks the tan of 105 in surd form. However, 60 plus 45 equals 105, and we do have the tan of 60, we do have the tan of 45. So what I can say is the tan of 105 degrees equals the tan of 60 degrees plus 45 degrees. So if I add the two of them together, then I should be able to get it. I've taken this from the logbooks. Tan A plus B equals tan A plus tan B over 1 minus tan A tan B. So this will be our A, this will be our B. And we'll set this up. So we have tan of A, I'll just tell you what tan of 60 degrees is and the tan of 45 degrees is. So in our logbooks, that's root 3, that's 1. So the tan of A is root 3 plus the tan of B, which is 1. That's over 1 minus the tan of A, which is root 3, multiplied by the tan of B, which is 1. And that will give us root 3 plus 1 over 1 minus root 3. We could leave it like that. However, we generally don't like surds as denominators. So if we want to get rid of that, we multiply it by the conjugate of the denominator. So that's 1 plus root 3, 1 plus root 3. And I would have showed you that trick before. So if you multiply the numerators together, you will get 1 plus 2 root 3 plus 3, and you'll get that by multiplying this by this, this by this, and then this by this, this by this. On the bottom then, if you do likewise, you multiply this by this, this by this, this by this, this by this, you will get 1 minus 3 equals 2. So simplifying all that, you will have 4 plus 2 root 3 all over minus 2. Okay, so that's the answer. Last one then. If tan A is a quarter and tan B is 3 over 5, find tan A plus tan B. Okay, right, so this is a quick one. Tan A plus B equals, and again from our logbooks, tan A plus tan B, 1 minus tan A B, which equals what? Tan A we know is a quarter, plus tan B, which is 3 over 5, over 1 minus tan A, which is a quarter, multiplied by 3 over 5. Now, in the leaving cert, they're not going to ask you to do it without using the calculator, okay? But, seeing as they've said here in the book, use it without doing the calculator, we would get a common denominator for the 4 and 5, okay? So we'd use that then to get rid of to get the common denominator. Okay, so you'll end up with 5 plus 12 over 20 minus 2, which is 17 over 17, which equals 1. And the tan of 1 is 45 degrees. Okay, thanks for that, guys.